First formula we have is the formula for the volume of a prism. And the most basic way we can talk about the volume of any prism, whether it's a square prism, rectangular prism, triangular prism, whatever, it is the area of the base times the height of the prism. Capital B means it's the area of the base, not just a single linear measurement. This is a calculated area. So take the area of the base, multiply it by the height. For example, if we have this triangular prism, we would need to figure out what is the area for this base, what's the area of this yellow triangle, and then multiply it by the height of that prism, and that would give us the volume, the amount of space we have on the inside. Here's our first example of actually finding a volume. We have a triangular prism. More specifically, it's a right triangular prism. It's a right prism because the lateral edges are perpendicular to the top and bottom, and also these bases are right triangles. So we're going to say the volume is capital B times H. Capital B is the area of the base. So as I look at this triangle, I need to find the area of that. Well, the area for the triangle on top is congruent to the area of the triangle on the bottom. So as I look at just that triangle at the bottom, I know that the area is 1/2 times 5 times 12. It's always 1/2 little b, little h when you're talking about a triangle. So if we multiply those together, we get 30. 30 is the area of one of those triangular bases. So we're going to plug in 30 for capital B then. And then this little h stands for the height of the prism. What's the distance between the top and the bottom? If I look at that distance is 10. So I'm going to plug in 10 for my little h. Multiply these together, and we get an answer of 300. Now we got to consider the labels as well. The capital B was 1/2 5 inches times 12 inches, which made that 30 inches squared. The 10 was also 10 inches, so we have inches squared times inches, which makes this volume become inches cubed. The answer is 300 inches cubed. For volume, it's always going to be some sort of unit, inches, centimeters, feet, yards, but it's going to be cubed. Volume is always something cubed. So the area of the base times the height. Here's our next example. We want to find the volume of this hexagonal prism. The volume is equal to the area of the base times the height. The bases are regular hexagons. So in order to find this capital B value, we have to find the area of the hexagon, then multiply it by the height of the prism. As I look at this 7 stands for the height of the prism. It's the distance between the top and the bottom. So I know that part of it's going to be equal to 7. But now I need to find the area of this regular hexagon, and that's going to take a little bit of work. So off to the right, we can start it over here. The area of the hexagon is what we're calling capital B. And if we draw a regular hexagon, what we know is that each side is equal to 8. And this side is 8 as well. But we're going to draw in a couple of segments. We're going to draw in an apothem that comes from the middle and is perpendicular to and bisects one of the sides. And we're also going to draw a radius. The radius comes from a vertex, and it goes to that exact center as well. And we've created this little right triangle. I know that this length now is 4. It's half of 8, so that length is 4. The other thing we know is the angle measurement of each angle in a regular hexagon. We have that formula n minus 2 times 180. That tells us the sum of all these interior angles. Since there are 6 sides, I'd plug in 6. 6 minus 2 times 180 tells us that's 720 degrees inside of this regular hexagon. Divide that by 6, and then each angle would measure 120 degrees. So use that little formula to figure out that 120 degree angle. And the reason why that's significant is because when I draw in this radius, I know what bisects that 120 degree angle to give us a 60 degree angle. Now we're going to work with this little right triangle down here. This length is 4. The apothem, which I'll call x, is something that we want to find. So from the 60 degrees, x is the opposite, 4 is the adjacent. Opposite and adjacent trig function is tangent. So it's a tangent of 60 is opposite over adjacent. That's just using SOHCAHTOA to set it up. Then using a little bit of algebra, I want to get x by itself, so how about multiplying both sides by 4? 4 times the tangent of 60 is equal to x. That's going to be an important number. And I'll keep it exact for a little while. Now that I know that length, I can find the area of this little yellow triangle. The area of a triangle is always 1/2 times the base times the height. So 1/2 times the base of 4 times the height, which is 4 tangent of 60. Multiply those together, and that comes out to 8 times the tangent of 60. That's the area of that one little yellow triangle. Because this is a regular shape, there's all kinds of symmetry in it. That yellow triangle is also congruent to this next triangle. There's 2 more triangles like it there. And in fact, there's a lot of those triangles as we go around this shape. There are 16 of them, or excuse me, 12 of them actually going around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 2 of them on each one of those sides. So to get the area of this entire hexagon, I'm going to take the area of this one yellow triangle, multiply it by 12 because there are 12 congruent triangles in there, and that gives us 96 times the tangent of 60 for the area of this regular hexagon. That's the area of our base. So go back over to the original problem. The volume is area of the base times the height. We already knew the height was 7. Now capital B is 96 times the tangent of 60. And we can go to the calculators at this point, multiply all that together, and that comes out to about 1,163.94 with the label of units cubed. It's nice to keep things exact as long as you can. We didn't have to round until we got to the very end. So again, general idea here is find the area of your base, multiply it by the height, and since this was a regular hexagon, it took a little while to get to that point. The next prism we're going to look at is a pentagonal prism. It's a regular pentagon base, and the volume of this shape is going to be the area of the base times the height. The height is going to be 20. That's the distance between the top and the bottom. We have to calculate the area of that base. So to do that, I'll draw in a regular pentagon, draw in an apothem, draw in a radius. And since each side of the pentagon is 12, that means that this little length is 6. And we have to do a little bit of work to figure out the measurement of this angle. Because there's 5 sides in a pentagon, we're going to use 5 minus 2 times 180 divided by 5 to get that each angle in a regular pentagon is 108. But when we draw that radius in, the radius bisects it, which means that this little angle down here in our triangle is 54 degrees. Using trig to find the apothem, I see that from 54 degrees, x is the opposite, 6 is the adjacent. So tangent of 54 is equal to x over 6. Multiply both sides by 6, and we get x. The reason why that's significant is because we can use that to find the area of this little gray triangle. Area of a triangle is 1/2 times base. Our base is 6 times the height. The height is represented by that x, which we just found to be 6 times the tangent of 54. And if we multiply all those coefficients together, we get that the area for that one little gray triangle is 18 times the tangent of 54. That's our first area that we have in this one. And it's just the area of that one little gray triangle, but we want the area of this entire pentagon. There's another triangle right next to it that's congruent as well. And in fact, on each one of the sides of this pentagon, there are going to be 2 triangles identical to that. So 5 sides times 2 triangles means there's 10 of these gray triangles inside of this pentagon. So the area of this is going to be 10 times 18 tan 54, 10 times the area of that one triangle. So the area of this base is 180 times the tangent of 54. That's the area of this pentagon. So now to find the entire volume, we're going to take that area times the height of this pentagon, which is 20. Multiply that together, and we get an approximate volume of 4,954.97 units cubed. So next we have volume of a cylinder. A cylinder is not a prism. A prism is not a cylinder. However, their volume formulas are virtually the same. Instead of saying capital B times H, we can put in pi r squared times H, because pi r squared is going to be the area of a cylinder. It's this area of a circular base. We're going to go right into an example for this one. So we've got this cylinder. We're going to say this length is 16, this length is 10. From that, we're going to calculate the volume. I'll write down my formula. Volume is pi r squared times the height. Pi times. Now 10 isn't the radius, 10 is the diameter. I don't want to use the diameter in this formula. If 10 is the diameter, that means 5 is the radius, so we're going to put in 5 squared. 16 is the distance from top to bottom, so 16 does represent the height. And then we can multiply all this together. 5 squared is 25, so 25 times 16 times pi gives us an answer of 1,256.64, and it is volumes, so that is units cubed. Cylinders are a little bit more straightforward. There's not a lot of variation to them. It's always going to be pi r squared times height when we're looking for the volume. The prisms had more variation because your base isn't always going to be the same kind of shape. In this next example, we have a volume and the area of the base. We're trying to find the height. So I'll go straight to my formula. The volume of a prism is the area of the base times the height. Now I'm going to plug in some numbers. The volume is 400, so I'll put that in for the V. The area of the base is 25. That's big B, that's area of the base, times the height. Now here's the equation to solve for H. We're going to do some algebra. Take 400, divide it by 25, and you get that H is equal to 16. And because this is just the height, it's not the volume itself. The volume was units cubed. The area was units squared, but the height is just 16 units. So we use our formula, we plug in what we know, and then we do some algebra to actually find that. In this example, we have a cylinder that has a volume of 600. The cylinder also has a height of 15 centimeters. Our goal is to find the radius of that cylinder. So I'll just write down my formula. The volume of a cylinder is pi r squared H. The area of the base is pi r squared times the height of the prism. Now plugging in what we are given, the volume is 600. The height was 15. Now we have some algebra to do. Our goal is to algebraically get r all by itself. So we would need to divide both sides by 15. Then we're a little bit closer to getting r by itself. Also divide both sides by pi. So then r squared is equal to 600 over 15 pi. It's pretty close to having r all by itself. At this point, you can go to your calculator and take 600 divided by the 15 pi. You can have a decimal on your calculator. That comes out to about 12.73 if you'd like to check that. We want to make sure we keep it in the calculator. If you didn't get the 12.73, maybe it's because you entered it in like this. That would take 600 divided by 15, but multiply it by pi. Make sure you put parentheses around that denominator. So 600 divided by the entire expression, 15 pi. And again, you should get about 12.73. That's what the radius squared is equal to. But since we want the radius and not the radius squared, you're going to have to take the square root of that. So if you've already done this first part on your calculator, then you're going to go to the square root of that answer. And you'll get that the radius is about 3.57 centimeters in. Don't take the square root of 12.73 because then you're using a rounded number, but take the square root of that answer. Square root of 12.73239545. All those decimal places are entered, and even more when you do square root of answer to give you the most correct, best rounded radius of 3.57 centimeters.